Each ball of mass m starts off stationary at height h above the slope, and when it hits the slope it has a downwards velocity of u. This can be calculated by conserving energy between these two situations. This velocity u can then be split into components which are acting parallel to and perpendicular to the slope. Because there's no friction, the component which is parallel to the slope will not change in a collision, whereas the one that is perpendicular to the slope will. As the collision is elastic and the slope does not move, this means that the speed of the ball will not change. All that happens is that the component of the velocity perpendicular to the slope switches direction. Adding this component to the unchanged component of the velocity parallel to the slope gives you the new velocity after the collision. In this question, we are trying to find the average force acting on the slope, so I have labelled the force of the ball on the slope as F and the force of the slope acting on the ball as minus F. We can then use Newton's second law on the ball to relate this to the change in momentum. Rearranging this, we can get the time sum of the force on the slope and relate that to the change in velocity of the ball, which is a vector addition. We can then work out the average force on the slope by taking this time sum and dividing it by the time between collisions, capital T.